Lesson 2.6, Solving Fraction and Decimal Equations. As we go through the next two examples on solving equations that have fractions, I'm going to show you a trick to help you eliminate the fractions, and it will allow you to solve the equation using all whole numbers. And then it's likely that we'll end up with a fraction answer. Maybe not, we might get a whole number, but often if our equation starts out with fractions, we should kind of expect that we might end up with a fraction answer. So let's look at this first example. 2/3 minus 1x equals 5/6 minus 1/3 x. We look at the denominators of our current problem. So we have 3 and we have 6. And we find a common denominator for both 3 and 6. I would encourage you to find the least common denominator, so the smallest one, but it will work even if you don't have the smallest denominator. Okay? So I know that 3 and 6 both go into 6, so I'm going to use 6 as my common denominator. And what I'm going to do is I'm going to multiply every single part of this problem by 6. Okay? Both sides. Every single term in the problem is going to get multiplied by 6. Okay? So let's start here at the beginning. Since 2/3 is a fraction, I'm going to make 6 into a fraction by making it 6/1. And I'm going to cross cancel. 3 goes into 3 once. 3 goes into 6 twice. So I multiply 2 times 2 is 4. 1 times 1 is 1, although the fraction 4/1 is the same thing as just 4. So really, we don't even need to have that over 1 part. Okay, now let's move to the second term. 6 times 1x is 6x. Let's move to the other side of the equation. I'm going to make that 6/1. I'm going to cross cancel. 6 goes into 6 once. 6 goes into 6 once. 1 times 5 is 5. 1 times 1 is 1, but I don't need that denominator of 1. And now let's move to the last term. Cross cancel. 3 goes into 3 once. 3 goes into 6 twice. 2 times 1x is 2x. Okay, now I have all whole numbers. Okay, I don't have any fractions left. I can just solve it with whole numbers. Remember, in the last lesson we talked about we want one side to be all the terms with variables, and we want one side to be all the constants. So I'm going to make this my variable side, and I'm going to make this my constant side. Okay, so let's add 2x and add 2x. Negative 6 plus 2x is negative 4x equals, on this side I'm left with 5, and on this side I still have a 4. Now let's move our constants all to the right hand side. So I do minus 4, and I'm left with, on this side, negative 4x equals, and on this side I have 1. Okay, I know that the opposite of multiplying by negative 4 is dividing by negative 4, so I'm going to do that on both sides. And remember what I said at the beginning. We began the equation with fractions. It's likely my answer is going to be a fraction. So when I get to this step and I have x equals, and on the other side I have this fraction, I'm going to leave that go. That's my answer. X equals negative 1/4. The only reason I would need to do any extra work here is if I had a fraction that wasn't in lowest terms, I would need to reduce it. Or if I had an improper fraction, I would change that to a mixed number. But I've got a fraction in lowest terms. I'm finished. X equals negative 1/4. Okay, now let's try this one. We have denominators of 10, 6, and 10. So I need a number that 10 and 6 will both go into, and I know that's 30. So I'm going to multiply every single term in this problem by 30. Okay, now I'll start at the beginning. Let's cross cancel. 10 goes into 10 once, 10 goes into 30 3 times. 3 times 3x is 9x. Okay, let's move to the term in the middle. 6 goes into 6 once, 6 goes into 30 5 times. 5 times negative 1x is negative 5x. Let's move to the last term. 10 goes into 10 once, 10 goes into 30 3 times. 3 times 7 is 21. So now we're ready to solve. I'm going to move my variables to the left-hand side, so I'm going to add 5x to both sides. 9x plus 5x is 14x. Negative 5 plus positive 5 is 0. And that leaves me with 21 over here. My last step is to divide by 14. Okay, so here's what I have. I have x equals 21 over 14. I started with fractions. I'm anticipating probably a fraction answer, which is what I have, 21/14. However, this fraction's improper, so let's make it into a mixed number. 14 going to 21 one whole time with 7 left over. So I have 1 and 7/14. And then that's a fraction that can be reduced. So let's reduce that to x equals 1 and 1/2. Okay, now let's look at an equation with decimals. Okay, when we have an equation with decimals, we're going to use a trick to get rid of the decimals. Very similar to that idea of eliminating fractions. With decimals, what we do is we take a look at our place value. And we're looking for the decimal in the problem that has the largest amount of decimals behind, the largest amount of digits behind the decimal point. So we have 2 digits behind the decimal point here, okay? What that means is we want to multiply by 100 because we want to move the decimal point 2 places. We want to move it to the end, okay? So to move the decimal 1 place, we multiply by 10. To move it 2 places, we multiply by 100. To move it 3 places, we multiply by 1,000 and so forth. So we are going to take every single number in this problem and we're going to multiply by 100 because we want to move our decimal point 2 times. Okay, so let's do that. This is 1m, so 100 times 1 is 100m plus, okay, we move our decimal point 2 times, so that becomes 674 plus, we move our decimal point 2 times, and in this open gap we fill in a 0, so that's 70m. And then we do that to the last term. We go forward 2 times, in this gap we fill in a 0, so that gives us negative 380. Okay, now you're welcome to use a calculator if you need to, because I realize when you eliminate decimals the numbers do get a little bit large, so feel free to use your calculator. Okay, let's combine our like terms. 100m plus 70m is 170m plus 674 equals negative 380. Okay, look, all of our constants are already here together on the left, so let's move, excuse me, I said constants. All of our variables are together on the left, so let's move our constants to the right. Okay, I have a negative 380 and a negative 674, so since they're both negative, we add, and we get negative 1,054. So we have 100m equals negative 1,054. We divide by 100 on both sides. Again, feel free to use your calculator if you need to. On this one, it's pretty nice because we're dividing by 100. So when you divide by 100, you just simply move your decimal point back 2 places. We get m equals 10.54, and we had a negative divided by a positive, so that means m is negative 10.54. Okay, let's try that trick with this problem. Notice that I have one decimal number behind the decimal, one number behind the decimal, one number behind the decimal. So all we need is to move our decimal point 1 place. That means we're going to multiply everything by 10. Okay, remember 1 place you multiply by 10, 2 places 100, 3 places is 1,000, and so forth. So we make this 43 plus 10y equals 41y minus 19. Okay, I'm going to put my variables on the right-hand side this time. So I'm going to say minus 10y minus 10y. Okay, that gives me, on the left-hand side, I'm left with 43, and on the right-hand side, I have 31y minus 19. Okay, now let's move our constants to the left. We're going to move our constants to the left. Let's add 19 on both sides. Okay, so we get 62 is equal to 31y. I divide by 31 to get y by itself, and I get y equals 2. This one came out as a whole number, okay? Sometimes it'll happen, but don't be surprised if you end up with a decimal answer. Now, as you move forward and you begin to practice these two skills, if you have any confusion, I want to strongly encourage you to plan to attend a teacher session. These tricks are very helpful to know. They do often make problem solving easier, but it does take a little bit of work on the front end. So please, if you have any confusion, plan to meet with a teacher and we'll do some examples together to help you to understand the trick better.